everyone. In this video, I would like to cover some of the basic information dealing with angles. We're going to take a look at the definition, we're going to take a look at how we notate angles, and we'll also take a look at how we classify them. So let's start with the definition of an angle. It says an angle is a set of points consisting of two rays that have the same endpoint called the vertex. So if we look at this definition and we break it down a little bit, I think we can put a picture with this. So the first thing is, it says it is a set of points consisting of two rays. So let's start with just one ray. So a ray has one endpoint and it goes on forever in one direction. So here's our endpoint and we'll call that point A. And then somewhere on this ray, it'll pass through another point and we'll call this point B. Okay? Now to make an angle, we need a second ray, and this other ray has to have the same endpoint. So we already have the endpoint A, so that's where we'll start our second ray, and then this goes on forever in a different direction. And then we'll put another point on there, so we have the endpoint A already, and then somewhere along the line this will go through another point, and we call this one point C. So there's an angle. That's all it is. It's two rays and they share an endpoint. And that endpoint, that's what we call the vertex. Now let's talk about how we notate an angle. There's a couple different ways that we can name this. So our notation, the first way that we can name an angle is we can just name it by its vertex. So here my vertex is the point A. So I could name this angle angle A. That would work. I could also be a little bit more specific, and I could name this angle based on three separate points. I could name it based on the 2 points that are on the rays and the vertex. So my options here, I could say angle BAC, or I could say angle CAB. Now I want you to notice the order of the letters here. In both cases, A, the middle letter in this name, is the vertex. And then the other 2 points, we can switch their order. So the way we name this, it's basically telling me how I travel around my angle. So for BAC, I start at point B, I travel over to my vertex A, and then I can travel over to my last point C, and it's describing the shape of the angle there. The last way that we can name an angle is if it's labeled for us. So let's say this angle was labeled down here in the corner as 2. Well, if that's there, I can refer to this as angle 2. Okay? Now the other important thing to note about all the different ways that I name these angles, they all include this angle symbol. And this is really important. When you're naming an angle, you need to include this symbol. Otherwise, we're not going to express exactly what we want to. So for example, if I don't have the angle symbol in front of A, well, now instead of talking about the angle, I'm just talking about the point A, which is not what we want. Or for the second ones with 3 letters, if I don't include that angle symbol, well, now instead I'm going to be talking about a plane. All right. And then the last thing I want to mention here is this second way, where I'm naming it with 3 letters, I have to use that method if I want to name an angle where more than one angle exists. So let me draw a picture and show you what I mean. All right, so here I have another diagram and I have another vertex A in the middle, but now I can't just say angle A. If I just say angle A, I could actually be referring to any of these 4 angles that exist at point A. So it's not specific enough. So if I want to refer to, let's say, this angle here, I need to use 3 letters in order to name that. I would need to use, for example, I could do angle BAC. That would take care of that. Or if I wanted to name this angle here. So the smaller one, this would be angle BAE, for example. But that eliminates any confusion. If I just say angle A, I could be talking about any of these. So we need to make sure that we're using the correct notation. Okay, the other thing to mention just with the basics about angles, when we refer to the space around an angle, we have two spaces. We have the interior. That's going to be everything in between the two rays that make up the angle. And then everything on the outside, this is the exterior. So these are just terms that are useful to know because when we're referring to location in the coordinate plane or just in space, sometimes we like to refer to things as this is on the interior of the angle or this is at the exterior. Okay, so now that we know what angles are and we know how to notate them, we can also talk about how we measure angles. So we measure angles with degrees. And the way that we're going to do this is with something called the protractor postulate. So I just want to give a quick explanation as to what that is. So the protractor postulate, we're going to start with a line. And let's call this line AB. And then in the middle, we'll put another point. I'm going to call this point O. And O is going to be the vertex of our angles. What the protractor postulate says is I can pick out any other ray on one side of my line. So let's say I want to take a look at the top half, so above my line. Any ray that I draw in here, so I can draw a whole bunch of them. And then these would go through some point, and maybe we'll call that point C. But any point I pick and any ray that goes through there, I can assign a real number value to this. So for example, I could draw in 180 different rays. Each one of those would represent 1 degree. So then what we're looking at is we're basically looking at how far do I need to rotate, and that's what a degree is. Okay, so in this case, maybe this one is 90 degrees. But in other words, that whole rotation everywhere above the line, that can be matched up 1-to-1 with the real numbers between 0 and 180. So 0 degrees would be down here, flat to B. That would be 0 degrees. And then if I rotate all the way over, and then I land on this side with A, that would be a full 180 degree rotation. So now that we know how to measure angles, we can actually use that to classify angles as well. We have a couple different ways. So it's all based on the size. So the first one is anything that is less than 90. These are acute angles. So less than 90 is an acute angle. The second option is if we have exactly 90. And if it's exactly 90, we can put a little box in the corner to indicate that it's a right angle. So exactly 90 is a right angle. And then if we get a little bit bigger yet, so now we're bigger than 90, but we're not quite to 180, this is what we call an obtuse angle. So our angle is between 90 and 180. This is obtuse. And lastly, if we get up to exactly 180, this is what we call a straight angle. And that name comes from the fact that it forms a straight line. So just like we saw in the protractor postulate, rotating all the way over and landing flat, this is a straight angle. This is exactly 180 degrees. All right, so I hope all that information was useful. We talked about the definition. We talked about how we notate an angle. It's really important to use the little angle symbol when we're naming angles. And then lastly, how we measure them and how we can classify based on their size.